Hello everyone. Welcome to another episode of Deep Dive Knowledge Talk. Welcome to our show. Today, we're discussing LightRAG, a Retrieval-Augmented Generation framework. LightRAG leverages graph structures for better text indexing and retrieval. It uses a dual-level retrieval system for comprehensive and efficient information retrieval, and an incremental update algorithm for adaptability to dynamic data environments. Stay tuned as we explore LightRAG's impact on sensitive domains like legal and healthcare. What are the main limitations of existing retrieval-augmented generation systems that have prompted the exploration of integrating graph structures into text indexing and retrieval processes?
Existing Retrieval-Augmented Generation, RAG, systems face some important challenges that limit their effectiveness. Imagine trying to build a puzzle with pieces that are all flat and don't show how they connect to each other. This is similar to how current systems rely on flat data residues. Because of this, the answers they provide can be like pieces of the puzzle that don't fit together well, resulting in fragmented and incomplete information. Additionally, these systems often lack adequate contextual awareness, which means they struggle to understand the relationships between different pieces of information. For example, if someone asks about how weather changes affect transportation, a traditional RAG might give answers that don't connect the dots between these topics. This can lead to responses that miss the bigger picture. To improve upon these limitations, integrating graph structures into the text indexing and retrieval processes is proposed. Graphs can represent the complex relationships between different entities, allowing for a more comprehensive understanding of how information is interconnected. This helps create responses that are not only more coherent, but also contextually rich, providing users with better and more relevant information.
How does the proposed LightRAG framework utilize graph structures to enhance the retrieval process? And what are the specific advantages of its dual-level retrieval system compared to traditional methods?
The proposed LightRAG framework enhances the retrieval process by utilizing graph structures, which act like a map showing how different pieces of information are connected. This allows the system to capture complex relationships between entities, similar to how a spider web connects various points. LightRAG uses a dual-level retrieval system, which has two main parts: low-level retrieval and high-level retrieval. Low-level retrieval focuses on getting precise information about specific entities, while high-level retrieval looks at broader topics and themes. This combination ensures that the system can handle a wide range of queries effectively, providing users with comprehensive and relevant answers. The specific advantages of this dual-level retrieval system compared to traditional methods include: 1. Comprehensive information understanding. The graph structures allow LightRAG to gather information from multiple related points, making it better at answering complex questions that involve different pieces of information spread across various documents. It's like being able to see the entire puzzle instead of just a few scattered pieces. 2. Enhanced retrieval performance. The system is designed to quickly and accurately retrieve information using optimized key-value structures from the graph. This is much faster and more precise than older methods, which often relied on less accurate matching techniques or slow ways of searching through data. Overall, LightRAG is like a smart librarian that not only knows where every book is, but also understands how all the books relate to each other, making it easier and quicker to find the right information.
In what ways does LightRAG's incremental update algorithm contribute to its adaptability and effectiveness in dynamic data environments? And how does this compare to the update mechanisms of existing RAG systems?
LightRAG's incremental update algorithm significantly enhances its adaptability and effectiveness in dynamic data environments. Think of it like a library that can quickly add new books without needing to reorganize the entire library every time. Instead of rebuilding the whole collection, LightRAG can integrate new information seamlessly, which saves time and resources. This algorithm allows LightRAG to process new documents using the same graph-based indexing steps as before. When a new document arrives, it merges the new information with the existing graph structure. This means that the connections and relationships already established remain intact. ensuring that historical data is still accessible while enriching the graph with new insights. In contrast, many existing RAG systems often require a complete reprocessing of their entire database whenever new information is added. This can be like having to close the library every time a new book comes in, which can lead to delays and increased computational costs. By avoiding this complete overhaul, LightRAG not only reduces computational overhead, but also maintains system accuracy and provides timely updates. In summary, LightRAG's incremental update algorithm allows it to adapt quickly and efficiently to new data, keeping it relevant and effective, while traditional RAG systems often struggle with slower and more resource-intensive update processes.
What experimental validations were conducted to demonstrate the improvements in retrieval accuracy and efficiency of LightRAG compared to existing approaches, and what specific metrics were used to evaluate its performance?
Extensive experimental validations were conducted to demonstrate the improvements in retrieval accuracy and efficiency of LightRAG compared to existing approaches. These tests focused on several key dimensions, including retrieval accuracy, response efficiency, model ablation, and adaptability to new data. To evaluate LightRAG's performance, specific metrics were used. 1. Retrieval accuracy. This metric assessed how well LightRAG could find and return the correct information in response to user queries. The results showed that LightRAG significantly outperformed traditional methods, achieving a much higher win rate in generating accurate responses. 2. Response efficiency. This measured how quickly LightRAG could provide answers after receiving a query. The integration of graph structures and the dual-level retrieval system contributed to faster response times compared to existing systems. 3. Diversity. This metric evaluated the variety of responses generated by LightRAG. It was found that LightRAG demonstrated a notable advantage in response diversity, particularly in larger datasets, such as the legal dataset. This implies that LightRAG could produce a wider range of relevant answers, which is especially valuable in scenarios requiring diverse content. 4. Model ablation. This involved testing different components of LightRAG to understand their impact on overall performance. It helped in identifying which features contributed most to improvements in retrieval accuracy and efficiency. The experimental settings included using 4 datasets from the ultra-domain benchmark, covering various domains like agriculture, social sciences, and legal studies. These data assets contained a substantial amount of text, allowing for a thorough assessment of LightRAG's capabilities. Overall, the results from these experiments highlighted that LightRAG not only improved retrieval accuracy, but also enhanced response efficiency and diversity, showcasing its advantages over traditional RAG systems.
How does the integration of graph structures with vector entities in LightRAG facilitate the retrieval of related entities and their relationships? And what implications does this have for generating contextually rich responses?
The integration of graph structures with vector entities in LightRAG creates a powerful system for retrieving related entities and understanding their relationships. Imagine a city map, the graph, combined with GPS coordinates, the vector entities. The map shows how different places are connected, while the GPS coordinates help you find the quickest route to those places. This combination allows LightRAG to effectively navigate through complex information. By using graph structure, LightRAG can represent the intricate connections between different pieces of information, like how different concepts relate to one another. This allows the system to capture both low-level details about specific entities and high-level themes that encompass broader topics. For example, if a query involves various related subjects, the graph helps identify the links between them, ensuring that the response is comprehensive and contextually relevant. The implications of this integration for generating contextually rich responses are significant. Since LightRAG can efficiently retrieve related entities and their relationship, it can provide answers that are not only accurate, but also deeply informed by the context of the question. This means that users receive responses that are well-rounded and take into account the complexities of the information involved. much like having a knowledgeable guide who understands both the details and the bigger picture. Overall, this synergy between graph structures and vector entities enhances LightRAG's ability to deliver coherent and contextually rich responses, addressing the needs of users more effectively than traditional methods.
What future research directions could be explored to further enhance retrieval-augmented generation systems like LightRAG, particularly in terms of improving contextual understanding and handling more complex queries?
There are several promising future research directions that could further enhance retrieval-augmented generation, RAG systems like LightRAG, particularly in improving contextual understanding and handling more complex queries. 1. Advanced graph structures. Exploring more sophisticated graph structures that can represent not just static relationships, but also dynamic ones. This could involve incorporating temporal aspects into the graphs, allowing the system to understand how relationships change over time, which can be crucial for queries involving evolving contexts. 2. Multi-modal integration. Investigating the integration of different types of data, such as images, audio, and video alongside text. By understanding and retrieving information from multiple modalities, the system could provide richer and more contextually relevant responses, especially for complex queries that require multifaceted understanding. 3. Improved query understanding. Developing algorithms that enhance the system's ability to interpret user queries more deeply. This could involve natural language processing techniques that identify nuances, intent, and context in user questions, enabling the system to retrieve more relevant information. 4. Personalization mechanisms. Implementing user-specific models that adapt to individual preferences and past interactions. By understanding user behavior and tailoring responses accordingly, the system could enhance the relevance and contextuality of the information provided. 5. Enhanced learning from feedback. Creating mechanisms for the system to learn from user feedback in real time. This could involve adapting the graph structures and retrieval processes based on what users find helpful or relevant, continuously improving the system's accuracy and contextual understanding. 6. Handling ambiguity and uncertainty. Researching ways to manage ambiguous queries or those with incomplete information. Developing strategies that can infer missing context or provide multiple potential answers with explanations could greatly improve user satisfaction. 7. Scalability and efficiency improvements. Continuing to optimize the retrieval process for larger datasets and more complex queries. This could involve refining the incremental update algorithms and enhancing the efficiency of graph operations to ensure quick and accurate responses, even in dynamic environments. By exploring these directions, future research could significantly enhance the capabilities of RAG systems like LightRAG, making them more adept at understanding context and handling the intricacies of complex queries.
How does the performance of LightRAG in generating contextually rich responses influence user experience, particularly in applications requiring high accuracy and relevance, such as legal or medical domains?
The performance of LightRAG in generating contextually rich responses significantly enhances user experience, especially in applications that require high accuracy and relevance, such as legal or medical domain. Here's how this impact unfolds. 1. Nuanced understanding of relationships. LightRAG's ability to effectively represent complex interdependencies among entities allows it to capture the intricate relationships within legal or medical information. This means that when users seek answers to their queries, they receive responses that consider the broader context and specific details, leading to more informed decision-making. 2. Comprehensive information retrieval. The dual-level retrieval paradigm enables LightRAG to gather both low-level specifics and high-level themes. In legal contexts, for instance, this means that users can access detailed case law, as well as overarching legal principles. While in medical scenarios, it can provide specific treatment options alongside general health guidelines. This comprehensive approach ensures that users have all relevant information at their fingertips. 3. Improved accuracy and relevance. LightRAG has demonstrated considerable improvements in retrieval accuracy compared to existing methods in fields like law and medicine, where precision is crucial. This heightened accuracy helps prevent misunderstandings or errors that could have serious consequences. 4. Diversity of responses. LightRAG excels in generating a wider range of responses, which is particularly beneficial in complex query situations. In legal or medical applications, users may need to explore various perspectives or treatment options. The system's ability to provide diverse responses enhances the user's understanding of the topic and supports better-informed choices. 5. Timeliness and responsiveness. The incremental update algorithm allows LightRAG to integrate new data quickly, ensuring that users have access to the most current information. In fast-paced environments like law and medicine, where new regulations or discoveries can emerge rapidly, this responsiveness is invaluable for maintaining accuracy and relevance. Overall, the enhancements brought by LightRAG not only improve the quality of information provided, but also foster a more engaging and effective user experience, making it a powerful tool in high-stakes fields that demand precision and contextual awareness.
What specific challenges might arise in implementing LightRAG in real-world applications, particularly in sensitive domains like healthcare or legal services, and how can these challenges be addressed?
Implementing LightRAG in real-world applications, particularly in sensitive domains like healthcare or legal services, can present several challenges. 1. Data privacy and security. Handling sensitive information in healthcare and legal contexts raises concerns about data privacy. Ensuring that user data is protected and compliant with regulations like HIPAA in healthcare or GPRE in legal contexts is crucial. To address this, robust encryption methods and secure access controls should be implemented, along with regular audits to ensure compliance with legal standards. 2. Accuracy and reliability. In sensitive domains, the consequences of incorrect information can be severe. LightRAG's performance must be validated rigorously to ensure high accuracy in generating responses. This can be achieved through extensive testing with real-world scenarios and expert reviews to confirm the reliability of the information provided. 3. Complex query handling. Users in healthcare and legal settings often have complex queries that require a nuanced understanding of context. While LightRAG's dual-level retrieval paradigm is designed to handle such complexity, ongoing research and development may be necessary to continually improve its ability to interpret and respond to intricate queries effectively. This could involve enhancing the system's natural language processing capabilities or implementing user feedback mechanisms to refine its performance. 4. Integration with existing systems. Many organizations in these fields already use established systems and workflows. Integrating LightRAG into existing infrastructures without disrupting operations can be challenging. To mitigate this, a phased implementation approach can be taken, allowing for gradual integration and testing in real-world environments. 5. User training and acceptance. Users in sensitive domains may be accustomed to traditional methods of information retrieval and may require training to effectively use a new system like LightRAG. Providing comprehensive training and support can help ease the transition and ensure that users are comfortable with the technology. 6. Handling ambiguity and uncertainty. In fields like law and medicine, ambiguity in queries is common. LightRAG must be equipped to handle uncertain or vague requests effectively, possibly by offering clarifying questions or providing multiple relevant responses. Researching methods for better ambiguity resolution will enhance the system's utility. By proactively addressing these challenges through careful planning, robust security measures, continuous improvement, and user support, the implementation of LightRAG in sensitive domains can be made more effective and reliable, ultimately enhancing the quality of services provided in healthcare and legal fields.
What role do user feedback and continuous improvement play in ensuring that LightRAG remains effective in evolving domains? And how can this feedback be systematically integrated into the system's development cycle?
User feedback and continuous improvement are essential for ensuring that LightRAG remains effective in evolving domains. Here's how they play a critical role and how this feedback can be systematically integrated into the system's development cycle. 1. Generate. User feedback as a learning tool. Feedback from users provides valuable insights into how well LightRAG meets their needs. By understanding user experiences, preferences, and pain points, developers can identify areas for improvement. For example, if users consistently find certain responses lacking in detail or relevance, this feedback can guide enhancements in the retrieval algorithms or the knowledge graph. 2. Iterative development cycle. To systematically integrate feedback, a continuous development cycle should be established. This could involve regular surveys and interviews, collecting user feedback through structured surveys or interviews at various stages of the application's use. This helps gather qualitative and quantitative data on user satisfaction and system performance. Usage analytics. Implementing analytics tools to monitor how users interact with LightRAG. By analyzing query patterns, response times, and user engagement, developers can identify trends and areas needing attention. Rapid prototyping and testing. Based on the feedback collected, developers can create prototypes of new features or improvements. These can be tested with a subset of users to gather immediate feedback before a wider rollout. This approach allows for quick adjustments based on real user experiences. Seamless integration of updates. LightRAG's incremental update capability allows for the integration of new features or adjustments without disrupting the existing system. This means that as user feedback is processed and improvements are made, the system can be updated smoothly, ensuring that users always have access to the latest enhancements. 5. Collaboration with domain experts. In sensitive areas like healthcare or legal services, collaborating with domain experts can provide deeper insights into specific needs and challenges. Their feedback can help refine the system's understanding of complex queries and improve the accuracy of responses. 6. Feedback loop mechanism. Establishing a structured feedback loop where user insights are regularly reviewed and prioritized for implementation can ensure that the development team remains aligned with user needs. This could involve regular meetings to discuss feedback and set goals for system improvements. By embedding user feedback into the development process and maintaining a focus on continuous improvement, LightRAG can adapt to the changing demands of its users and remain a valuable tool in dynamic and sensitive domains. This approach not only enhances the system's effectiveness, but also fosters user trust and satisfaction.
How can the integration of advanced technologies, such as machine learning and natural language processing, further enhance LightRAG's capabilities in providing contextual understanding and accurate information retrieval?
The integration of advanced technologies, such as machine learning, ML, and natural language processing, NLP, can significantly enhance LightRAG's capabilities in providing contextual understanding and accurate information retrieval in several ways. 1. Improved contextual understanding. Machine learning algorithms can be trained to recognize patterns in language and context. By leveraging these algorithms, LightRAG can better understand the nuances of user queries, allowing it to interpret complex questions more effectively. This leads to responses that are not only accurate, but also contextually relevant, reflecting the user's intent more accurately. 2. Enhanced entity recognition. Natural language processing techniques can improve the system's ability to identify and extract entities from text. By accurately recognizing names, dates, locations, and other critical information, LightRAG can build a more comprehensive knowledge graph that captures the relationships between these entities. This enhances the system's ability to retrieve relevant information quickly and accurately. 3. Semantic search capabilities. Integrating ML and NLP can enable LightRAG to perform semantic searches rather than just keyword-based searches. This means that the system can understand the meaning behind the words in a query, allowing it to retrieve information that is contextually related, even if the exact keywords are not present. This is particularly useful in complex queries where users may use different terminology. 4. Adaptive learning. Machine learning can facilitate adaptive learning, where the system continuously improves its understanding based on user interactions and feedback. As users engage with LightRAG, the system can learn from their preferences and adjust its retrieval strategies accordingly, leading to increasingly relevant and personalized responses over time. 5. Handling ambiguity. Advanced NLP techniques can help LightRAG manage ambiguous queries by generating multiple potential interpretations and responses. This capability allows the system to provide users with a range of answers, enabling them to select the most relevant one based on their specific needs. 6. Dynamic data integration. By using machine learning algorithms, LightRAG can efficiently process and integrate new data into its knowledge base. This ensures that the system remains current and relevant, adapting quickly to changes in information and user needs without requiring extensive manual update. 7. Enhanced user interaction. Natural language processing can improve the overall user experience by enabling more natural interaction. Users can ask questions in a conversational manner, and LightRAG can respond in a way that feels intuitive and engaging, making it easier for users to find the information they need. In summary, the integration of advanced technologies like machine learning and natural language processing can significantly enhance LightRAG's ability to provide contextual understanding and accurate information retrieval, ultimately improving its effectiveness in meeting user needs across various applications.
What considerations should be taken into account when designing user interfaces for LightRAG to ensure that it is accessible and easy to use, particularly for non-technical users in specialized fields?
When designing user interfaces for LightRAG to ensure accessibility and ease of use, particularly for non-technical users in specialized fields, several key considerations should be taken into account. 1. Intuitive design. The interface should be user-friendly, with a clear layout that guides users through the process of querying and retrieving information. Using familiar icons, straightforward navigation, and logical flow can help users feel comfortable interacting with the system. 2. Clear language. Avoiding technical jargon and using plain language is essential. The interface should provide explanations and descriptions that are easy to understand, ensuring that users from specialized fields can grasp the functionality without needing technical expertise. 3. Contextual help and tooltips. Including contextual help features, such as tooltips or help buttons, can assist users in understanding how to use different parts of the interface. These can provide brief explanations or examples when users hover over or click on specific elements. 4. Search functionality. Implementing a robust search feature that allows users to easily input queries and filter results can enhance usability. Users should be able to search using natural language, and the system should interpret their intent accurately. 5. Visual feedback. Providing visual feedback, such as loading indicators or confirmation messages, can reassure users that their actions are being processed. This is particularly important in applications where users may be waiting for results. 6. Responsive design. Ensuring that the interface is responsive and works well on various devices, desktops, tablets, smartphones, is crucial. Users may access LightRAG from different environments. So, a consistent experience across devices enhances accessibility. 7. Accessibility features. Incorporating accessibility features, such as screen reader compatibility, keyboard navigation, and adjustable text sizes, ensures that the interface is usable by individuals with disabilities, making it more inclusive. 8. User-centric testing. Conducting usability testing with real users, especially those from the target specialized fields, can provide valuable insights into how the interface performs in practice. Feedback from these sessions can guide iterative improvement. 9. Customization options. Allowing users to customize their interface experience, such as saving preferences or creating personalized dashboards, can enhance user engagement and satisfaction. 10. Training and resources. Providing educational resources such as tutorials, user guides, and FAQs can help users learn how to use LightRAG effectively. Offering training sessions, especially for users in specialized fields, can also improve their confidence in using the system. By considering these factors, the design of LightRAG's user interface can be made more accessible and user-friendly, ensuring that non-technical users can effectively utilize the system to retrieve accurate and relevant information in their specialized domains.
Thank you all for joining us today. I hope you found this discussion informative and engaging. To recap, we've explored LightRAG, a cutting-edge retrieval-augmented generation framework. Its dual-level retrieval system and graph-based approach enhance text indexing and retrieval, while its incremental update algorithm ensures adaptability to evolving data. LightRAG's superior accuracy, efficiency, diversity, and adaptability make it a valuable tool in various domains. Future research will focus on advanced graph structures, multi-modal integration, and user-centric interface design. Remember, LightRAG's contextual understanding and accurate retrieval are essential in sensitive areas like law and healthcare. By embracing these capabilities, we can unlock new possibilities for information retrieval and knowledge discovery. Thank you once again for your participation.